We are given this logistic growth model of population of a certain species after some time t, and this is given as p of t equals 280 over 1 plus 34 e raised to the power of negative 0.16 t. And we have to answer this question: when will the population become 50? So it's basically that we are given population at certain time t is given as 50, and we have to find the corresponding t. So which means I can replace this p of t equals 50 into this equation or into this model. So when I do that, I get 50 equals 280 over 1 plus 34 e raised to the power of negative 0.16 t. Now I have to solve this equation for t. I have to solve for t. I'm going to consider this 50 as 50 over 1, and I'm going to do the cross multiplication. So therefore it becomes 50 times of 1 plus 34 e raised to the power of negative 0.16 t. This is equal to 280 times of 1 is 280. So I'm going to distribute this 50 into the terms inside the brackets. 50 times of 1 is 50, and 50 times of 34 is equal to 1700. So it becomes 1700 e raised to the power of negative 0.16 t, and this is equal to 280. Now we can subtract 50 from both sides. So we have to do that so that we can solve for the t. So when I do that, I will get 1700 e raised to the power of negative 0.16 t. This is equal to 280 minus 50, which is equal to 230. Now divide both sides by 1700, because we have a factor 1700 multiplied with this exponent. So when we do that, we get e raised to the power of negative 0.16 on the left side, and this is equal to 230 over 1700. We can approximate this. When you plug this into the calculator, we get the value as 0.13529, and then this numbers keeps recurring. It's just continuous. It's not a terminating. Or we can just keep this quantity as it is, because we are going to apply the logarithm on both sides. So I'm going to, it's better I consider this as a fraction. So let me rewrite this. That is e raised to the power of negative 0.16 t. This is equal to 230 over 1700. Now let me apply the natural logarithm on both sides. So I apply it like this: natural logarithm, as well as for this quantity. Now when we apply the properties of natural logarithm, this power rule, using the power rule, this power comes in front. So therefore this becomes negative 0.16 t, and then multiplied with the natural logarithm of e, and this is equal to, we will have this quantity as it is, natural logarithm of 230 over 1700. Now we have to simplify this. We know the natural logarithm of e equal to 1. So therefore this quantity becomes 1, which means I can just remove this. I'm going to remove this. So we now have negative 0.160 equals the quantity on the right side. So to solve for t, we have to divide both sides by negative 0.16. So therefore t equals natural logarithm of 230 over 1700. This is divided by negative 0.16. And now we can plug this into the calculator. And when we do that, we get the t as approximately 12.50 years. And this is the answer for this question.